Alright, so let's start today's training about the AI Builder Advanced. So today in this training course we will include 4 parts. So firstly we will introduce some previous knowledge that we have mentioned last time in our AI Builder basic training. After that we will introduce a complex case and we will introduce how the procedure about how to realize it to help you better understand the process of designing a complex AI. And third part, so I will propose a practice question, and you can practice with this question with our AI builder after the training. And the fourth part, this is a Q&A section. So the first part, so let's have a review about our AI Builder basic training. So what is AI Builder? So AI Builder is an evolutionary editor tool of LifeSmart, and it can make the invisible AI logic to be intuitively displayed on our app, and it will help people to have a very simple and convenient way to program their DIY AI templates. So the AI Builder, it simplifies the complex AI logics, and it can also make the AI templatized. So every time you create an AI, you can just very easily to share it with your friends, so that the other people, they do not need to create again. It can also enhance the reliability of device interaction and scene linkage. So by default, the AI Builder function was not enabled on our public accounts. So you will need to contact our engineer to enable that function in your account, so that you can enjoy the convenience of AI Builder. So here are some basic AI Builder concepts. So there are mainly 3 concepts that you will need to understand. So first, the control block. So a control block consists of a group of inputs and outputs, and it represents processing the data from the inputs and update the data in the outputs. So we always say the logic of a control block, how to deal with the data, determines the function of the control block. And with a combination of a multiple of control blocks, and we can realize a lot of very complex AI scenes. And joint lines. So the joint lines, it connects 2 data points. So you will always see some green lines with arrows, which indicates the direction. So these are the joint lines of an AI. So the joint line is directional. So you will see a green arrow in an AI template if you edit it. And joint line represents sending data from source point to a terminal point. And inputs and outputs. So a control block can contain many different data points, and every data point in a module has its own meaning. So data is transmitted through joint lines from the source point to the terminal point. So next, I will introduce some frequently used blocks. So these function blocks are used frequently in our normal AI design. So first, on the top left corner, you will see a device control block. So with the device control block, you can easily control some simple devices such as switches and plugs. So you can use this device control block to realize the turn on or turn off actions of these simple devices. And please note, for some complex device control commands such as PTZ of the camera or the IR commands of the remote, you will need to use the device action block. And besides the device control block, there's a time limit block. So the time limit block, it will so you will need to set start time and end time, and when the actual time is within this time period, it will trigger an output on the other side, and you can use the output to trigger devices. So for example, you want to trigger to turn on the light every day, say 7 a.m. to 8 a.m. So you in this case you can use the time limit block. And next one is the send message block. So send message block, it is used to send messages to different users, and you can input the contents of the message as well. And you can also set the sound, the notification sound of when you receive the message. So this block is normally used when an event is triggered, and we want to do something with this trigger, and then we can put the send message block here. And in the bottom, we have three logic operator that is frequently used. So we here we listed an AND and an OR operator, and there's a Boolean operator which will provide a 0 or 1 status. So next, the second part. So here I will propose a complex case and introduce a step-by-step about how to realize it. So the case is about night mode and back home mode. So firstly, let's see the night mode. So the night mode says from 21 p.m. to 5 a.m. when there's no movement in living room area for 30 minutes, I want to turn off the lights and air conditioners, and also to close the curtain. And for the back home mode, we say during 5:30 p.m. to 6:30 a.m. when you get back home, and if there's nobody in the living room, I want to turn on the lights and air conditioner, and also to open the curtain. If there's someone in the living room, then just do nothing. So if you compare these two cases, you will see that the common point is to detect the event of no movement in living room, or in other words, no one in living room. So this is a key point that we need to realize in this case design. So let's see a logic diagram of accomplishing this case. So in this case, we will have three comparison conditions. So from start, the first condition is whether the time is between 9 p.m. and 5 a.m. If the answer is yes, then the system goes to the next step of the motion sensor. And motion sensor will determine whether a motion was detected. If a motion was detected, then it means that there is someone in the living room, and we shouldn't do anything in this case. So it will go back to the motion sensor again. If there's really no motion detected, and then it will go to the next step. So it will count and see whether the time of nobody in living room, no motion detected, lasts for 30 minutes. If no, that means there is a movement between during this 30 minutes period. So the motion sensor should start detecting again. If yes, the no motion status is really lasts for 30 minutes, then it will trigger the turn off scene, which means to turn off the lights and air conditioners, and also close the curtains. So this is the whole procedure of how the system should work, and the way of each part that work with each other. So with this logic diagram, next we will need to select the modules to realize each part functions. So firstly, how do we detect nobody in living room this event? So definitely we will need to use a motion sensor here, which can provide movement status. And imagine we have imagine normally that the living room should be very big, very large, and sometimes it may have a lot of motion sensors to cover the whole area. So we want to collect the data of these motion sensors and compare of all of these motion sensors, and finally we can conclude whether there is someone in the living room or not. So to realize this, we want to use an OR operator. So it will compare all the input from the motion sensors statuses, and then only when all the motion sensors give a 0 signal, and then the output of the OR operator is 0. So in this way, it means that no motion was detected in all of these motion sensors. And if you can remember that we have mentioned in the last AI training, so we call a trigger only when the signal changes from 0 to 1. So this is a trigger. So if the signal always keeps 0, or always 1, or it changes from 1 to 0, so these conditions cannot be called a trigger. So the output of the OR operator, as we mentioned before, it is 0, and we will need to use a signal 1 to have a trigger, so that we can trigger the rest modules and devices, right? So in this case, we will need a 1, signal 1. So to realize this, we will need to use a NOT operator. So the NOT operator, it will reverse the status from the input and give a reversed result in the output. And next, because we will need to count 30 minutes when there's no movement was detected in the living room, so that we can conclude that there is really no one in the living room. So to count 30 minutes, we should use a timer block. So the timer block, it can receive a trigger and start to count, and we just need to set 30 minutes as a condition, and then the output will be triggered if the 30 minutes has been met. And the last thing, because we will need to trigger the lights and curtain actions. So to do that, we can easily design a scene on our app directly. So this part does not need to be designed in the AI builder, because it will be very troublesome and not so convenient, because you will need to use a lot of device control blocks to realize the control actions for every device. So if we use the scene design, the scene template directly in our app, so it will be very easy. Okay, so let's see the partial realization of this AI. So the first part is the realization of detect human presence. So this is the key point, as we mentioned before, in this AI. So the modules that will be included in this AI, so they are the four-way OR, which is used to collect data from 4 motion sensors. If we assume that the living room has 4 motion sensors, and we will need a two-way OR, and to connect the output of the four-way OR and also the output of the timer, so that it can realize automated control and to refresh status. And we also need a NOT operator, which we mentioned that to reverse the status. And also we need a timer here to count for 30 minutes. So the design block, or the design scheme, is as the picture showed on the right hand side. So the four motion sensors was being loaded to the four-way OR of the four inputs. So they will compare the status of these 4 motion sensors, and it will output a 0 if these 4 motion sensors all have a 0 status, which means there's no one in the living room, and it will go to the input of the two-way OR, and in the beginning the output of the timer is also 0. So the result of the two-way OR is also 0 in the beginning. So it will not, because the output of the two-way OR is connected to the reset of the timer, and a 0 signal will not trigger the reset. Also the output of the two-way OR, it will also go to the NOT operator, and after the reverse of the NOT operator, the output will become a 1. So this will trigger the start of the timer, because there's no one in the living room. And we set the condition of the timer to be 1800 seconds, because the timer only accepts second as the time unit, and 30 minutes equals to 1800 seconds. So it will start to count. And what if during this 30 minutes and there's a motion happened? So let's see from the beginning. Now the timer start to count, because it detects no one in the living room. And if any of these 4 motion sensors detects the movement event, so the output will become 1 immediately of the four-way OR, and it goes to the two-way OR, and so that the output of the two-way OR will be 1. And this 1 signal will trigger the reset of the timer. And this is what we want, because once the living room detects human presence again, the timer should restart to count, because a movement was detected. And we say the output of two-way OR is 1 now, and after the reverse of the NOT operator, it will become a 0. So a 0 will not trigger the start of the timer, because a movement was detected. So this is the whole logic of the detect human presence function module. And by the way, there's another way of realization of the detect human presence, and it will become more easy to understand, and the whole design will be simplified. So in this case, we can use a delay on block. So the feature of a delay on is it will accept a trigger signal from the input to start to count, and once the input becomes 0, it will stop to count immediately and to refresh the counting. And if the counting condition has been met, it will trigger an output to turn on devices. So let's see the logics again. So still we have 4 motion sensors in these 4 inputs of a 4-way OR. If there's no movement was detected in this 4-way OR, the output of the 4-way OR will be 0. After the NOT operator, it will become 1, which will trigger the start of the delay on module, and the delay on module start to count for 1800 seconds. And during this 30 minutes, if any of the inputs of the motion sensor detects a movement, the output will become 1 immediately, and after the NOT operator, the signal will become 0. So the input of the delay on will receive a 0. So it will stop the counting immediately, and meanwhile it will refresh the counting value. And we will also need to restrict the time period to make the AI only works from 9 p.m. to 5 a.m. So to do that, we use a time limit block that we have introduced before, and we set the condition to be every day 9 p.m. as a start time, and the end time set it to be 5 a.m. So as long as the actual time is within this time period, it will make a trigger in the output. And thirdly, the device control. So because the final function of this AI is to turn off devices, because there's when there's no one in the living room. So to control these devices, we can set a scene in our scene template. So if you go to AI menu, and on the top right corner click the plus sign and select create AI, and we select scene. And in the scene menu, we can select different devices, and the actions of these devices. So for example, in our case, we created a lights off scene, which turns off lights. So we can use this scene laterally in our AI. So this will make the AI very easy and convenient, because we don't need to use device control blocks, a lot of device control blocks in our AI to control the actions of these devices. And fourth part, after we have designed the scene to turn off the lights, we can use the AI action block to trigger this scene. So we can only use the AI action block to trigger a scene, or to start an AI, or to pause an AI. And it looks very similar. This block, it looks very similar with device control block and also device action block. And many people may be confused about these three blocks. So here, so let me explain again. So device control block, it can be used only to trigger some very simple devices, such as the on-off status of switches and plugs, and some very simple color effects to change color effects of some simple devices, such as the smart bulbs. And for device action block, it is used to trigger some complicated actions of devices. For example, to trigger the PTZ of the camera, and or to trigger the IR remote control commands of an IR remote. And the AI action, it is used to trigger the AI or a scene. Okay, as we have designed all the function modules, and finally we just need to connect them together, and we have a finalized AI as displayed here. So the four-way OR and the time limit, so they represent two conditions. That is whether there's someone in the living room, and also if the time is between 9 p.m. to 5 a.m. And these two conditions will go to an AND operator. So only when these two conditions are met, and then it will trigger the timer to start to count. And after the timer, if the timer has that output, that means there's no one in the living room for 30 minutes, it will trigger the actions of the devices, which is to turn off the lights. So here I want to ask a question: is it really finished? So for this question, I mean, is there anything that we can do, or do we have a better solution for this? So here, please remember that we should also need to design a scene of an AI of the back-home mode. So for the back-home mode, as we mentioned before, it will also need the status of nobody in living room as the trigger condition. So in this case, do we need to create the same modules again in the back-home mode? This will be very troublesome, because we need to select these blocks again and connect the lines, and also to set the interface characteristics again. So this will become troublesome sometimes if the AI is very complex and contains a lot of function blocks. and or we can use the no one in living room as a status, so that we will need some kind of indicator to indicate indicate this status. So do we need an actual device such as a switch on-off status to indicate this living room no one in living room status? This will be not so cost effective, because it will need another device. So what can we offer to realize this? A very simple way is to use a status indicator. So the status indicator is a virtual device that has been built in our smart station. So it is especially used for AI triggering. So in every smart station there are 9 status indicators in total. So they are just like a virtual switch that has already been added to smart station. So we can use the on-off status of the status indicator to refer to that whether there is someone in living room this event. So how do we enable the status indicator in a smart station? So firstly, we go to All Device menu, and we find a smart station. And in the bottom of the drop-down list, we will find a status indication menu. Click that. There will be a 9 status indication listed in the interface. And click the Open button to enable the status indication. So in our case, we only need one status indication. That is enough to represent whether there is someone in the living room event. After you have enabled the status indication, so you will see light. You will see a light has been displayed in the drop-down list of status indication. Okay, so after we have enabled the status indicator, and we can do some modifications to our existing AI. So we get an output from the output of the 4-way OR operator. So we put that 4-way OR, the output of the 4-way OR, to a device control, and we set the command to turn on, and we set the device to be status indicator 1, and we turn on the status indicator to refer to there is someone in the living room, and we get the output of the timer, which refers to no one in the living room, and we use the turn off status of the status indicator to refer to this event. So after that, we can just use the status of the status indicator 1 to refer to these 2 different events, and we can use this status in the following design of the beacon mode. Okay, so this is an optimized AI. So as we can see, it is very simple and just uses 3 blocks to realize this function, this night mode function. So what we have here is, for example, the time limit block and the end block and the AI action block. So the time limit block, as before, it is used to determine the time, whether the actual time is within that time period. So this will go to the input 1 of the AND operator, And the input 2 of the AND operator, we use the status indicator 1, and we use the off status of the status indicator 1, which refers to no one in the living room. If these two conditions are met at the same time, it will trigger the AI action block to trigger the lights off scene. So as you can see, after the optimization, the whole design will be very simple, and we can even use this living room status in our back home mode, without recreating the same function modules again. So about how to realize the back home mode, we will not discuss more in this training, and you can just try in your own AI builder with what we have introduced today. So next, I will give some tips about how to design a complex AI. So firstly, we should clear up the logic flow. So as we mentioned in the very beginning, we draw a logic flow, a logic diagram about the whole AI. So this will help us to understand step by step that how we realize it is this AI, and how the system, the different parts of the system work with each other. And second, we should choose the appropriate modules. So for example, we have device control, device action, and AI control. These three different modules all have different functions, and we should choose the right modules to realize the function. Otherwise, it will not work. And always use existing AI and themes as much as possible. This will simplify the AI design greatly. So in our case, we just to control the devices, we just create a scene in our app with a public scene template. So this saves a lot of time and effort for us to create the same device control functions in the AI builder. Always think about system optimization and AI portability, and so this is very helpful when you are designing a lot of AIs with a part of them similar with each other. So in our cases, the back home mode and night mode. So the common thing is to detect the human presence in the living room. So we can just and we use a status indicator in our case, which makes the living room status to be able to be used in both of these AI. So this also makes the AI design very simple and easy. Finally, keep modular design in mind, and we should always design each function module separately, and finally connect them all together to simplify AI design and debug. So third part, this is a practice question. So you design an AI which can realize the following functions. So here I give a question. I give a practical case that you can practice with it, and also with your own AI builder after training. So the case is every day during 8 and 9 a.m. when you leave the home and press the door window sensor click button, and then delay 10 seconds to arm the house, which means when the door is open or motion sensor detects the movement, and the system should send push notifications to the mobile phone and also to sound the alarm. And when coming back during 5 and 6 p.m., press the door window sensor click button to disarm the house. So in this case, I'll give some advice about this case. So in this case, the common thing is, so we can still separate this case to be two parts. So the first is to arm the house, and second is to disarm the house. So these two small cases, they have a common thing is the arm status of the house. So we can just design the arm status of the house firstly, and then we just use this this arm status or the arm AI in these two cases, and then we can just very easily realize these two AI at the same time. And the final part is the Q&A section. So here I have created two questions already. So first is, can I debug the AI that I have created? So the answer is yes. After you select the devices for the AI, on the app AI's editing menu on the right hand side, there will be an I button, as you can see in the picture. If you click that I button, the AI will simulate the running status of the AI, and you can check the different status of each part and see if there's something wrong and do some modifications. Second is about how our device's actions are executed. So the device actions, they are carried out according to the AI logic in the AI builder, and there's no concepts of stable mode or fast mode, etc. So these stable mode and fast mode, they only exist in the scene creating. So when you create a scene on our app, in the scene menu, the final step is to select the stable mode, fast mode, or the merge mode. So these concepts are only for the scene, and for the AI builder, it just all the commands are carried out according to the logic and also according to the joint line, how the joint line goes. Okay, so these are the contents for today's training, and if you have any questions, you can ask me now.